This is Mr. Mitchell, one of the Coosa High School physical science teachers. And in this particular video, I'd like to talk about significant figures. There are rules for significant figures whenever you are doing calculations. But before we look at the rules, I'd like to try to explain why we have something called significant figures in the first place. And it has to do with being precise in your calculations. In our class, we will have this formula: speed or velocity equals distance over time. And you can see some sample numbers here. Distance traveled 7.23 meters and time is 4.16 seconds. Here's why you have rules for how many of these figures should be in the answers. If you are measuring the distance someone travels in a certain amount of time, you are limited with the instrument in which you are measuring it with. If you are measuring in meters, you probably have some meter stick or some kind of tape measure. The tape measure will only go to like the tenths, hundredths, or thousandths place. So when you measure 7.23 meters, it could actually be more numbers past that. 7.231759 or 7.230485 or something like that, but you don't know because your instrument will only go to the hundredths place. So as a result, whenever we do calculations with this type measurement, we really can't go past the number of figures that are in our measurement. In this particular measurement, we have 1, 2, 3 digits, which are the three significant figures. So one of the rules is going to be that any number that is a non-zero, and 7, 2, and 3 are all non-zeros, is going to be a significant figure. So you only have the preciseness of this measurement to 1, 2, 3 figures. Take a look at this thing for seconds, at this measurement for seconds. You probably could use some kind of stopwatch, or probably use something similar to measure this. And the stopwatch will only be so precise. It probably will even say 4.16, when in reality it could be 4.16437, it could be 4.16059. We don't know if it doesn't read past the 4.16. So as a result, any calculations you have must only go to the same number of figures. If you are to look down here, I punched in 7.23 meters, which is the distance, divided by 4.16 seconds, which is the time. So why don't I put what I had here. The speed equals 7.23 meters. And in the calculator, I would type that in and press divided by 4.16 seconds. So as a result, what I got was this crazy number right here. And you know, if I were not thinking, I would probably just write this in as the answer, or maybe just round it to a figure that seemed reasonable to me. But there are rules for this. If you are as only precise as 3 digits, then you have to just use 3 digits here. So let's say we have 1 digit, 2 digit, 3 digit, and then you would round up or stay down depending on what the next number is. And in this case, it's a 7, so you would round it up. So what you would have is 1.74 meters per second. As you can probably see why, oh, that's an awful looking fraction mark there. But still, it's 1.74 meters per second. And you can see why you would not include any of these, because in your original measurements, you don't know if what is past these, if it just doesn't read that high. So you have to go with that number of significant digits. Does that make sense? I hope it does. We're going to have some practice opportunities for you that you'll see on another slide. Speaking of another slide, I do have some rules that are going to be here, and the question is, how many significant figures are there? One rule I did mention is that every non-zero number is significant. So let me get to this here. Every non-zero number is significant. So if I have 1.245, all of these are non-zero numbers. So you would have 4 significant figures here. Any calculation you have with this must have at least 4 digits. Now, there's an exception. If you have 2 that have different numbers of digits, you go to the lowest calculation, and we'll get to that in an example later on. Okay, here you see that every 0 between non-zeros are significant. So we have 1, 2 zeros here that are between significant numbers. So yes, they are significant also. So you have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 significant figures here. What about this rule, and how does it apply? Zeros to the left of the first significant figure are not significant. So you do not count any of these zeros as being significant unless you had a significant figure on the other side of them. So here you just have 1 significant figure. What about this next rule? Zeros to the right of the first significant figure are significant. So here you would have 1, 2 significant figures. Now notice what happened. We had a similar something in number 3 as we had to number 4. But these zeros were not significant because they were on the left, and you did not have another significant figure out here. This 0 is significant, and I suspect it's because your measurement was accurate to this hundredths place. And that is why you would count it as significant, because it was accurate to that place. What about this one? 5 is tricky. Zeros to the left or decimal are significant. However, if scientific notation is being used, it is not. So here, if you leave it as it is, you have 1, 2, 3, 4, 5 significant figures. But if you were to call this 5.3 times 10 to the 1, 2, 3, 4, I'm making all kinds of marks, 10 to the 4th, then you would only have 1, 2 significant figures. Does that make sense? So why don't we go to another slide and we can have a little bit more practice. And like I said, you'll end up having a worksheet and can always go back to here to see if you can see how it goes. Okay, so here we have the calculations. What I have done is I have put 2 numbers next to each other with a dividing, multiplication, or I guess this is subtraction, multiplication, and adding. And I'd like to see if what I put in the calculator, what showed up in the calculator, is correct according to significant figures. So let's see. With this particular calculation, how many significant figures are here? None of these are zeros, so that is 4 significant figures. Here you have how many significant figures? You have a 0, but it is between 2 significant figures, so you have 3 here. Hey, I talked about this earlier. What if you do have different numbers of significant figures? The rule is that you go with the one that has the least amount. So our answer should only have 3 significant figures because this measurement is only as precise as what it shows here. So you just cannot go past that. So let's see what the answer happens to be. The answer happens to be 1.315. Is that in 3 significant figures? No, it's in 4. So you only include the 3 significant figures, and the next number to the left may have you round up. And yes, this particular number is 5 or higher, so you would round up. So the answer would be 1.32. That's 3 significant figures because you only had 3 there. I would put units, but there are no units signified here. What about this one? How many significant figures are here? Is it 2 or is it 3? It's 1, 2, 3. You may remember if it's to the right of the numbers, it is a significant figure. And of course, this is 3 also here, so you know the answer should be in 3 significant figures. Is it? It is not. You have to only count this one, and this one, and the 2 will not have it round up. So that answer is 9.10 and whatever units you would have if units were specified. What about this? How many significant figures are here? Do you have these zeros counting as significant figures? You may remember the rule. The answer is no. If it's to the left and you do not have another significant figure on the other side of it, they do not count as significant figures. So you have 1, 2. What about here? What do you have now as significant figures? Is it 4 or is it 3? Well, using the same rule, this particular 0 is not going to be a significant figure. So you have 3. So when I see the answer is 0.337, do I go with 2 significant figures or 3? You have to go with the lowest number because that's your degree of accuracy. So you have to go with 2 significant figures. So this is not a significant figure, but this and this are. So you would look to the number to the right, I should say. I think I said left earlier. You would look to this next number to see if you would round up, and yes, you would. I'm going to go ahead and put the 0 there because it is not a significant figure. So it does not count against it. So I will have 0.34 is the answer. You can see that we have a practice URL here. You may have gotten this worksheet anyway, but if you have not, you can go to this tinyurl.com/Y65N65V5 and you can have some practice on significant figures. I hope this was helpful.